This time we're going to have a look at the polymerization of polypropene. So propene looks like this. Here's the model of it. So we can see we've got the double bond between the two carbons here. Each carbon has 4 bonds, which means that we've got 2 hydrogens there, 1 hydrogen on the middle carbon, and 3 hydrogens on the end carbon. So the chemical formula of that is C3H6, and if I draw the structural formula, it's going to look like this: carbon, double bond, carbon, 2 H's on the end, and then I've got 1 H on the middle carbon, and then I've got 3 H's on this carbon here. Now in a polymerization reaction, as we know, there would be lots and lots of monomers joining together. So here's a second propene, and here is a third one. So I'm going to draw these ones out as well. I'm just going to show you a couple of different ways of drawing them. So double bond, 2 H's on the end, 1 H on the middle. Now this time I'm going to show this as CH3. Okay, so C, double bond C, H, 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 and this time I'm just going to show it as a straight chain with 3 hydrogens on the end. So there are some slightly different ways of drawing polypropene. So let's have a look at how the monomers join together. In order for the monomers to join and make a polymer, the double bond has to open up. So firstly, I'm going to open up all of the double bonds. That then allows each monomer to bond to the next one. So I need to join them together. So the monomers then bond together, making the polymer chain. So what I end up with then is a long chain of atoms, otherwise known as a polymer. Now if I untangle this and find the 2 ends and show you what it looks like, I've got a long chain. But it's a bit different to the chain in polythene, because this time I have these CH3 groups sticking off the chain. Okay, so there's one there, there's another one here, and there's a third one towards the end. Okay, so I need to try and draw out what that polymer chain looks like. So here we go. I've got carbon, and now there's no double bond anymore because the double bond has opened up. I had 2 H's there, H there, a H down there, and I'm going to write the CH3 group like this. That was then attached to the next one. So same thing, H, H, H. But this carbon had a CH3 sticking off of it. Onto the next one, and again I've got 3 H's, and then I've got the CH3 sticking off. Now if you have a close look at the chain, you can see that on the left hand side there is a bond which allows it to bond to the next monomer in the chain. And in actual fact, in the polymerization, millions and millions of monomers would join together to make a polymer. So next we'll have a look at how to show that as a chemical reaction. To write the symbol equation for this polymerization, I need to show the monomer as the reactant on the left. So I've got the carbon with its double bonds, 2 hydrogens, and this carbon had 1 hydrogen and that CH3 group attached to it. I need an arrow to show that that's going to turn into a product, and then I need to represent the polymer chain on the right hand side as the product. Now in my reaction up here I had 1, 2, 3 lots of the monomer, so I'm going to draw a large 3 to show 3 lots of the monomer. Drawing the polymer is a little bit harder. What I'm going to do is I'm going to look up here at the polymer chain, and I can see that these atoms all came from that first monomer, these ones came from the second monomer, and these ones came from the third monomer. and you can see that it's the same pattern of atoms each time. So as the product, to represent the chain, I'm going to draw one of those. So I've got 2 carbons, the hydrogens, and that CH3 group. I'm going to put the bracket around it, and then I'm going to put a bond starting inside the bracket and moving outside to show that that is able to bond to the next part of the chain. Now here I had 1, 2, 3 units in that chain, so I'm going to draw a small 3 down here. Now, as we know, in a real polymerization reaction, there wouldn't just be 3 monomers joining together, there will be millions and millions and millions, very large number, don't know exactly how many, so we use an N to represent that. So I'm going to draw the monomer again. So there's propene, C3H6, and I'm going to show that actually there would be N lots of that monomer, N meaning millions and millions, very large number, don't know exactly how many it would be. In the polymer then, we're going to write out the atoms that were in that section of the polymer chain. I'm going to put the brackets, I'm going to put the bonds showing that it is able to bond to the next part of the chain, and then I'm going to use a small n on the right hand side to show that there will be millions and millions of those units in the polymer. So this equation now reads that n lots of propene monomers join together to make a polymer chain which is n units long. This then is the symbol equation for the polymerization of propene to make polypropene.